So Coulomb's law. First condition of Coulomb's law, first and most important condition of Coulomb's law is it is valid for charged particle. In the very first class, I told you the definition of particle. Did I? Did I told you the definition of particle? Yes. I told you infinity. I told you point mass. What I told you? They are reference quantity. I told you that point mass means its dimension is negligible. Infinite means its dimensions are very, very large. This pen is a point mass in comparison to the size of the earth. This pen is an infinite length in comparison to the size of a molecule. Yes or no? Same thing, if the charged bodies are there, how you can treat them as a point charge? You can treat these bodies at a point charge only when this distance between them is much, much larger with respect to their sizes. Yes or no? Suppose if I say that I have a charged body which is of the size of a ball. But suppose if two charged balls are there and they are kept at a distance of, let us say, 100 meters, then size of the ball is negligible as compared to that 100 meters. So how you treat those bodies? Point. But if those balls will be very near, I cannot treat them as a point. Samajh mein aaya? Everybody? So first thing is what? That Coulomb's law is only valid for particles, not for continuous bodies, not for large bodies. If it is a large body, I have to go for superposition, integration and all those things. But formula, if I want to directly apply the formula, I can only apply the formula if charges are quite far as compared to their dimension. All right? All right? Now, second, you can see this force is directly proportional to the magnitudes of the product of the magnitude of the charge. So as this is a law will be always derived by experiments. Just suppose I am doing the experiment, I kept 1 Coulomb. I am getting some force between them. At the same distance, when I replace one charge by 2 Coulomb, the force will be double. When I replace the another by 3, the force will be 6 times, 2 into 3. So this is how what we got to know, that it is a multiple of Q1 and Q2. All right. So experiment shows that it is Q1 and Q2 proportional to Q1 and Q2. Coulombs did this experiment, and it is reciprocal to the square of the distance between them. So again, same experimental data. If you kept it at 1 meter, let us say you are getting a force of F. But when you increase this distance to 2 meters, the force will be 1/4 times. That means this got to know that it is reciprocal to 1/r square. All right? All right? So if I combine them, I will say F is proportional to Q1, Q2 by r square. And if I remove this proportionality sign, then experiment shows that this is having this constant value, which is K Q1 Q2 by r square. So magnitude of the force, this is just a magnitude. Magnitude of force between the 2 point charges is given by K Q1 Q2 by r square, where K is 9 into 10 raised to the power 9. Ab unit is Newton meter square per Coulomb square. Newton meter square per Coulomb square. This K is also written as 1 upon 4 pi epsilon naught. 4 pi epsilon naught, which is 9 into 10 to the power 9. So with the help of this, we can also find out epsilon, which is 1 upon 4 pi into 9 into 10 to the power 9. इसका वैल्यू 8.86 into some 10 to the power कितना हो जाएगा 36 pi. 36 pi means 100, so 1000. So minus 12, and unit will be Coulomb square by Newton meter square. All right. This particular thing is called permittivity of free space. Permittivity of free space, or you can say of air. Permittivity of free space or air. जैसे suppose if I say you have two balls, one is of iron, one is of plastic. Which is heavy? Iron. How do you decide? You will say, sir, iron is having more density. So for the same volume, it is having more mass. Yes or no? That means density is the criteria which is telling you the specific property of that material. Same thing when I am talking about epsilon naught. Epsilon naught is telling you the order, how this medium which is lying between Q1 and Q2 allow them to interact. But obviously, if the charges are exerting the force to each other, they are interacting. They are interacting through the field lines, and those field lines are passing through air. So air is having some order that, okay, I will allow you this. If instead of air, if I change some other medium, the order of permission will be changed. That means permittivity will change. So permittivity is telling you what? That what is the order of their interaction. Understand? Just like it is telling you that if it is a air, it is permitting up to certain level. If it is some other medium, it will permit to some other extent to interact between them. So that's why that particular order of permission is decided by their permittivity. Understand? And that's why if there is any other medium, for any other medium, this permittivity is given by epsilon. This permittivity is given by epsilon, which is given as epsilon naught R, epsilon naught. This epsilon naught R is called permittivity of the medium by permittivity of air, and this is called relative permittivity. Its value is always greater than 1. Its value is always greater than 1. And this relative permittivity is also denoted by K, capital K. This is small k. Don't confuse with this K and this K. This is small k, which is 9 into 10 to the power 9. This is capital K, which is the relative permittivity, which is called dielectric constant of the medium. This is also called dielectric constant of the medium. All right. All right. That means if the two charges are placed in some medium at a distance r, then the force will be 1 upon 4 pi k times of epsilon naught. Why k times of epsilon naught? Because now I am using epsilon naught of the medium into Q1 Q2 by r square. That means the force which is they are interacting, force which they are exerting on each other in the medium is 1 by k times of the force in the air. All right, everybody, whatever they are experiencing in air, in the medium, they are experiencing 1 by k times less. If medium is 2, if the medium is having dielectric constant 2, force will be half. If the dielectric constant is 3, force will be 1/3. If the dielectric constant is 4, force will be 1/4, like that. So in the medium, the permission allowed is even more less. That's why force will be decreases. Till now it is clear? Okay. Here we can put one question which is very, very common question. Very, very common question, and many times it is being asked in JEE also, in NEET also, and chances are there it will be asked in your test also as well as in the exam, which is very simple question. What is the dimension formula of epsilon naught? So what is the dimension formula of epsilon naught? You can do that. Try karo. Dimension formula of, to find out the dimension formula, it is very easy. Simply whatever is the unit, convert into all the MKSSI. All right. So here, can I proceed? Here, my first question is, if I ask you what is the dimension formula of epsilon naught, how you go? You will say, sir, I know the unit of dimensions, which is Coulomb square upon Newton meter square, correct? Everybody? Newton is not MKS. Coulomb is also not fundamental. Is the Coulomb is fundamental? What are fundamentals? 7. Mass, length, time. So charge is not fundamental, but current is fundamental. So Q is equals to current into time. That means this coulombs can be written as ampere into second. Yes or no, bacho? Say yes. Yes, sir. That means what is the unit of epsilon naught now? Ampere square, second square upon coulombs is, Newton is kg meter per second square into meter square. All right, which means it is kg minus 1. It is meter minus 3. It is second power 4. It is A2. So what is the dimension formula? Everybody, m minus 1, L minus 3, T4, A2. Okay. 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 Next type of question. Next type of question is, second example. If I say two charges are there at a distance r in the medium of dielectric constant K. Okay, dielectric constant K. What is the equivalent distance? What is the equivalent distance of the charges in air? Okay, this is the next question. What does it mean? See, what does it mean? It means if I say the force, what is the force, बच्चों? K Q1 Q2, ये इसको K से हटा के एप्सिलॉन नॉट के टर्म्स में रखते हैं, आदत पड़ी हुई है. Q1 Q2 by 4 pi epsilon naught K into R square. All right. If we are calling about this R equivalent thing, what does it mean? It means I need the same force. If the same charges are placed at some distance R equivalent in air. That is the meaning. They are asking what is the distance between the charges, equivalent distance in air. That means to get the same force. So to get the same force, can we equate this by KQ1 Q2 by 4 pi epsilon naught into R dash square? That is the meaning of equivalent. Everybody. So now can you get this? What is this R equivalent? R equivalent square is equals to K times of R square. That means what is R equivalent? It is under root of K into R. That means if the distance is R in the medium, then in air it will be root K times of R. All right.